Okay. For number 19, we've got angle EOF is 26 degrees. Angle FOG is 38 degrees. What is the measure of EOG? This is angle addition. And so the measure of this EOF and FOG, if we just add them together, that's going to give us our total. So I'm just going to do 26 plus 38. So the whole angle should be 64 degrees, angle addition. All right, this says angle MO bisects angle LMN. So remember, angle bisector cuts this into two equal angles. So I'm just going to mark both of those as congruent. It says angle LMN. So LMN, the whole thing, is the 5x minus 23. LMO, which would just, let me grab my highlighter here. LMO, just to here, is going to be x plus 32. And if these two angles, if they told me that MO bisects that, so this angle here also has to be x plus 32 as an expression. So if I want to find x in these angle measures, what we're going to do, these two added together will give me the entire angle. So I'm going to say x plus 32. X plus 32 again, since they're congruent, has to add up to the whole thing, which is the 5x minus 23. So we got 2x plus 64 if I combine my like terms here. Totally up to you. I like to keep my variable positive if I'm solving that, so I would subtract 2x from both sides. That'd give me 64 is equal to 3x minus 23. And then, of course, I'm writing too big, so what I'm going to do here, just rewrite this real quick. I'm going to add 23 to both sides to get it away from here. So I'm going to get 87 equal to 3x. And then what I need to do there is divide by 3. And x is going to be 29. Now, all you have to do, if you want to plug back in to find angle measures, NMO would be this angle just right here. So all I'm going to do, that's the x plus 32. Now I know that x is 29. I just add those together. So 29 and 32 is going to give me 61 degrees for angle NMO. Okay. For number 21 here, we're going to do two things. It says use the distance formula to find the length of PQ, and then we're also going to find the midpoint. Okay, so two ways to do this. These 2 points, I'm just going to jot them down real quick here. This is the point 2, 6, and Q is the point -6, -8. So if you are a distance formula person, we can use the distance formula. So I'm going to just label these points, whoops, x1, y1, x2, y2, and I'm going to go ahead and follow my distance formula. We take the difference in the y-coordinates, so I'm going to do -8 minus 6 squared, and I add that to the difference in the x-coordinates, so -6 minus 2 squared, and I'm going to get -14 squared plus -8 squared. And then remember here, as you do this, you've got to simplify the inside under the radical before you take the square root. So this is 196 plus 64, and then the square root of that is going to give you 260. That's not a perfect square, so I'm going to break this down. I'm going to use a factor tree. So, let's see. I'm trying to think. This would be 2 and 130. I'm just going to break it down by 2s, 2 and 65. And then 65 can break down, but I don't think we're going to have any more pairs. This is going to be 5 and 13. These aren't a pair though, so I have a pair of 2s here. I need to, since these don't have a partner, we don't need to do this step. I'm just going to put those back together. So what would be left under the radical would be the 65. So I have a pair of 2's. This should be 2 radical 65 in simplest radical form. The other way you can do the distance, if you would like, is I'm going to turn this guy into a right triangle. And I'm going to set up the Pythagorean theorem because the segment I want to try to find the length of would be the hypotenuse. So there's distance formula. If you want to do Pythagorean theorem, I can just count boxes here. This goes from -6 over to 2, so that distance is 8. This goes from -8 to 6. This distance is 14. And maybe we call that side C. So we have our a squared plus b squared equals c squared. So you're going to see I'm going to end up actually with exactly the same math when I do this because I end up squaring 8 and 14. So again, I get 64,196, which is the 260. Take your square root, and then the answer, we already did this, should be the same here. So that's going to be 2 different ways to find the distance. Okay, now for your midpoint. Okay. Midpoint, you take the 2 x coordinates of the endpoints, average, so I'm going to add them together, divide by 2. And same thing for the y coordinate of the midpoint, it's an average of the y coordinates of the endpoints. So I'm just going back to my points so you guys can look at the graph. My 2 x coordinates are 2 and -6. And my 2 y coordinates are 6 and -8. So simplify both of these. This would be, -4 over 2. This would be -2 over 2. And both of those can be divided. So this is going to end up being -2, -1. And that's going to be my midpoint there. All right, and then for 22, this is similar to the question we just did. It says a segment RS has these endpoints, 2, 7, and 10, -11. What are the coordinates of the midpoint? So again, I'm just going to use my average of my x coordinates, x1, y1, x2, y2. So for the midpoint, you take the x coordinate of each point, 2 and 10, add them up, divide by 2. It's just an average. And for the y coordinate of the midpoint, take your 2 y coordinates, add them up, divide by 2. Here I would have 12 over 2. And here I would have -4 over 2. Both of those, again, can be simplified kind of like the last question. So the midpoint here should be 6, -3. And forgive me on that last one. This should be -2. Sorry about that. This should be 6, -2. All right, for number 23, area of the shaded region. So it looks like all the sides are marked the same around the outside of this figure. So this is going to be a square. What I'm going to do is I'm going to take the area of the whole thing, which length times width or base times height would be 15 times 15, which is 225. And what I want to do is I want to subtract the little rectangle in the middle that is not shaded. So to do that, the area of that would be, again, length times width or base times height would be 8 times 6. So the whole thing, if it was all shaded in, would be 225. I'm going to subtract out the area in the middle there, so I'm going to do 225 minus 48. So 177, this is square feet, would be my answer for that question. 24 says find the area and the perimeter both. So if you guys remember the markings, if this is a double mark, any double mark is going to have the same length. So this would be 5, this would be 5, this would be 5. And any single mark is going to be 3. So 3, 3, 3. All right. And then I'm just going to go around the outside of the figure to get the perimeter here, and I'm going to lay my calculator. Now, especially if I have a lot of sides, I like to try to make sure I don't count them twice. So I'm going to go, and I'm just going to start here, and I'm going to highlight around as I go. So I've got 5 here, plus another 5, plus this 5. Then I got a 3, then I got another 3, and then I got a 5, and then I got a 3, and then I got one more 3. And I just kind of highlighted as I went around there because I didn't want to I wanted to make sure I didn't skip a side or I didn't count a side twice. So here, perimeter is going to be 32 just plain inches. And then this also says find the area. Completely up to you how you want to do this. I'm just going to break it up just like this. I'm going to put a little line right there. Now, this portion of it is 5 by 5, length times width or base times height. So multiply those together, I'm going to get 25. This rectangle here is 3 by 5. Multiply 3 times 5, you get 15. Add the areas together. 25 and 15 is going to give you 40, and that's going to be inches squared. Okay. For 25 and 26, we're going to use this picture over here. So angle 3, right? I can name an angle by a number that is in between the 2 rays that make up either side. So that's the angle I'm talking about that I highlighted. Another way to label that angle, and since I've got more than 2 rays coming into this point, I can't just use the vertex, which is R, for the angle I'm talking about, because it could also describe other angles in the diagram. So I got to use 3 letters, and you got to touch them in order around the angle. R should be in the middle. So I could call this angle TRG, or I could call this angle GRT. Those are your 2 options. Okay, now it says kind of the same thing. RIG. Name this in 2 other ways. Oh my goodness. Totally forgive. Okay, ignore that for a second. I just totally labeled the wrong angle. I'm going to redraw this picture real quick. Okay. Here's R. Here's I, here's G. I did not highlight that correctly. Okay, this is the angle I'm talking about. I is the vertex. Okay, so this situation, I only have 2 sides to the angle coming into the vertex, so I can call that angle I. And then if I call it RIG, the other way I could label it would be to go the other way and say GIR. It is appropriate there, not where I labeled it here. It is appropriate to label that angle I since I only have 2 sides coming in there, whereas in the last one it was not appropriate to label something R because I had 3 different segments going in there. Okay, let's look at 27. That's going to go with this picture here. So it says ZVW, so this entire thing is 145 degrees. ZVY, which is going to be this guy here, is x plus 5 as an expression. XVY, which is this guy here, is going to be 3x. And then it doesn't say this in the directions, but I do have these marks right here to indicate these 2 angles are congruent. So by that marking, what's going on there is your angle ZVY is going to be the same measure or congruent to, same thing, as WVX. So if this guy, this ZVY is x plus 5, so is this. I'm going to use angle addition here. So this angle plus this angle plus this angle make up the entire 145 degrees for the whole overall angle there. So I'm going to take the x plus 5, the 3x, and the x plus 5. We're going to add those up, set that equal to the 145. Okay, I'm going to combine like terms. So I have 1x, 3 more, so that'd be 4, and then 1 more, 5 x's. 5 and 5 is 10. Set that equal to the 145. If I subtract 10 from both sides here, we're going to get 5x is 135. And I'm going to divide both sides by 5 there. So x is going to be 27. And if I want to plug that back in to find the angle measurements here, I'm going to just grab a different color real quick. 27 and 5 would make this angle 32. This angle would also be 32. And 27 times 3, which is what we would do there, is 81. And if you wanted to check that real quick, 32 plus 32 plus 81 does add up to the 145. All right, for number 28, find the distance between these 2 points in simplest radical form. So I'm just going to call this x1, y1, x2, y2, and I'm going to go ahead and use the distance formula here. Since I don't have a graph. If you wanted to make a graph, you could make a graph and do the Pythagorean Theorem, whatever your preference is. I just don't have a graph picture here. So for y2, I'm going to find the difference in the y-coordinates. So I'm going to do y2 minus y1 to be 1 minus a negative 5. You add in between here, difference in the x-coordinates. So x2 minus x1, so minus a negative 4 again here. If I simplify this, this is going to give me negative 1 plus 5, which is going to end up being 4 squared. And this is going to give me 3 plus 4 minus a negative there, so it'll be 7 squared. And I wrote too big. This is 16 and 49. I want to add those together first, which is going to give me 65. And 65 you can divide by 5 and 13, but it's not going to have any partners. So for simplest radical form, this is going to be it. It's going to be square root of 65. Okay, now for number 29, it says how many yards less would it be to cross the rectangle diagonally than to walk from star to star around the outside of the rectangle? Okay, so if we rocked from star to star, one way I could do that would be to go here. I could do the same thing. It would be the same distance if you went across the top and down the right side. I just went down the left side and across the bottom, so both of those would give you the same. So if I go that distance, it would just be 110 plus 60, which would be 170 yards. Now, if I cut across diagonally, this is just forming a right triangle when I do that. So instead of walking around here, if I cut through, what would the difference be? I got to find this side. This would be your hypotenuse in a Pythagorean theorem. The two legs would be the 60 and the 110. So I'm just going to do Pythagorean theorem here real quick. And 60 squared is going to give you 3,600. 110 squared is going to give you 12,100. I'm going to add those together. So we're going to get 15,700. And we are going to take the square root here. Now, this says round to the nearest tenth. So that's what I'm going to do on my calculator. I'm going to take the square root of 15,700. And hopefully you guys can see that okay. Actually, this 0.99, this would actually round up to 125.3. So 125.3 to the nearest tenth there, which is going to give us that diagonal distance. So if we walk around the outside, it's going to be 170. If we cut across diagonally, it's 125.3. So to get the answer to this question, we got to subtract those real quick. So it's going to be 44.7 yards would be the difference. And that would be what I'd be looking for the answer there. Okay, now one last question. This says find the value of A and the measure of each angle. So it's given us angle measures here. If you guys remember, if you have a straight line, those two angles, where I've got the ray there, these two angles added together, since I'm talking about angle measures, have to add up to 180 because I have a straight line. So I'm doing angle addition, the 3A plus 31 plus 2A minus 6. Those two angles form a straight line, 180. Combine my like terms here. So I got 3A and 2A is going to give me 5. Let's see, 31 minus 6 is going to give me 25. And I didn't leave myself a lot of space here. I'm going to subtract 25 from both sides. So 180 minus 25 will give you 155. And then what I'm going to do there is divide by 5. So A there is going to be 31. Now, that's not the angle measure. If you want to find the angle measures, you got to plug that back in. So here's A. Now, I'm going to do for this angle 3 times 31 plus 31. So this guy's going to be 124. Now, you got two options here. You could just subtract 124 from 180 to find this angle, or again, you can plug in the 31. 2 times 31 minus 6. Either way, it should give you the same answer. This is 56. These two angles add up to 180.